we're good to
And
go.
then Hunter, just FYI as well, you don't need to be in the. In fact, you don't want to be on the actual stage. You can open up the chat in Discord, but you don't want to open up the actual stage because then it'll play back the video and you'll have reverb.
Okay. I'm
So,
sure that'll make sense at some point.
yep, you're totally fine, man. I got all this stuff. So, do.
Stop sharing here.
Yep, you're good to go stop sharing. There we go. All right, we are live, everybody. What is going on?
What's
Howdy,
up?
folks. Okay, so now that I've confirmed we are live, if we could get maybe a few folks in the comment section to just confirm that they can hear us okay on Discord and on YouTube. So that way we make sure everything is kosher before we consider moving forward. I'm going to disconnect right here. Yep, people on Discord saying they can hear us. That is awesome. Let me head over to YouTube and pop open that chat there real quick and make sure people can hear us there as well. And then we will do the damn thing. Time for upslope regimes. All right. I love how with the Storm Chaser Coaching YouTube account, I pay for YouTube Red personally,
Hmm.
but we don't
Yeah.
have it for the YouTube account for Storm Chaser Coaching. So every single time I click over thinking I'm about to check to see if the stream has started, I get some political ad for Ohio. John Husted has said no to more Medicare spending.
I can't wait for this like period of more political ads to go away
Yeah,
before
dude,
we
it's
dive into presidential elections in a year.
and then it's even worse.
Oh,
So
it's gonna get much worse.
they spend so much freaking money on these ads, and I just can't. I can't for the life of me figure out who's ever going to have their opinion changed by a YouTube ad telling them about the bad things someone else did that they didn't already know about.
Right,
But
right.
anyways, folks, you're not here to listen to Hunter and I talk about politics, or maybe you are, in which case you should check out our podcast next week, where we're actually going to be discussing all the midterm elections. No, I'm just kidding, but
It's time to leave. It's time to leave.
time to leave at that point. So, welcome everybody. We're going to be talking about upslope regimes here. This, of course, is one of the more fun presentations because you get to learn about how to watch some, I would say, Hunter, very low stress, beautiful, picturesque type storms. You don't really have necessarily the craziness of Dixie Alley or maybe some of the more powerful events that you get in the plains. You can kind of just enjoy the scenery and have fun with upslope regimes.
This is true. Yeah, Colorado is, and I shouldn't say just Colorado, New Mexico, Colorado, Wyoming, Montana. These are all really easy, usually I should say easy storm modes to chase, usually by speed. Sometimes they can get messy, and I have chased some 60-mile-an-hour moving storms in Colorado once upon a time. Last time actually was in 2021, but it's very, very rare, and I love that it's rare.
Yeah, man, the high cloud bases are what sells it for me. That's what makes it exceptionally sort of laid back is you can just see the things from so far away. You don't even
Hmm.
necessarily need to get close and put yourself at any risk at all and you can still get something beautiful.
Yeah, absolutely. Just the visibility, usually higher cloud bases, and I tend to prefer the more convective looking storms because usually your LCL is near your LFC. So you tend to have these very crunchy convective looking storms. So I'm always a fan. It's easy storm chasing.
Well, we will give folks a few more minutes to filter in here before we have you start the presentation, Hunter. And before I ask you a couple of questions to get the ball rolling, though, I do want to remind folks that this, of course, is free for everyone. So if you're in here right now, awesome, on YouTube, on Discord, we are very thankful that you've decided to join us tonight. But if you want to ask a question, which there will be a Q&A session at the end of this, you either have to be a member in our Discord server or a member on YouTube. You can join either place wherever you happen to be watching this right now, but that's just basically to make sure we don't have a million questions that keeps Hunter here all night. He's got a bebe that he has to take care of. Unfortunately, he can't stay here all night. I wish he could.
I do have things to do.
Yep, yep. You, it's been funny actually. I've been following along in our team chats where you've been talking about the new computer that you're putting together. So how's that been going along?
Yeah, actually, funny enough, I am currently on the new computer. Hello, hi, it's very fancy and nice. I put together a new PC pretty much over the last couple of days. I had to order all sorts of parts, completely brand new. Everything in here is brand new. Found some nice deals that tied in a motherboard with a CPU and RAM, so that was pretty much the catalyst for jumping in and doing it. And plus, my old PC decided to stop working. Two USB ports stopped working. It blue screened after freezing, after four freezes and then a blue screen. So that caused me to full panic, and so it's new computer time. I mean, I've been thinking about it for a year, but with how insanely expensive everything in computer land has gotten, I have been trying to push it off as long as I could. But when my computer started to not do so well, and I found some deals, we said let's go ahead and do it. But yeah, RAM prices are straight criminal, and that's all I need to say.
Dude, it's kind of crazy between the prices for chips and the prices of Pokemon cards and fuel, so that you can't get out and storm chase. Nerds are getting squeezed at every turn, man. It's not
Uh,
easy. It's not easy being a nerd these days.
No, no, it's not. And not to mention, yeah, gas prices for me. So I haven't done much storm chasing as of late because it's too far, too dead, or too expensive. It's
Yeah,
tough out here,
when you're
guys.
talking about like a 50% increase in the fuel prices, and then hotels aren't getting any cheaper. I've noticed that just over the last few years the prices have been creeping up. It's really tough to find a place for less than 130, 140 bucks after tax if you want to stay anywhere respectable. So it's getting rough out there.
Although to be fair, on a real long storm chase journey, are you really staying anywhere respectable? No, and that's part of the charm.
You may have to talk to Trey about that, because I felt it in my soul when we were doing his tour earlier this year. It had to be at least like a 4.5 rating out of 5 stars, or else he wasn't staying there. That man is not about the
You know
nasty
what?
hotel life.
You want to know what? I think it's part of the charm, and I'm not making the big bucks like Trey is. So,
Very true, very true. All right, well, I think that's enough chitter chatter back and forth. I think people have had a chance to filter in here. So, Hunter, I'm going to go ahead and pass the baton over to you if you'd like to get started and let us know how we can chase storms out there in your area of the country.
yeah, and thank you, Gabe, for this, so we can talk a little bit more about some upslope regimes. And I actually did a previous presentation about upslope regimes, so we're not going to do too much recap on that per se. So if you can, I would highly recommend go check out that previous video where I talk a lot about the basic types of upslope regimes you can kind of look for and various important little tidbits of information. That's a good place to go back and kind of get some basic refreshers. In this little episode or section, we are actually going to talk about examples of some upslope regimes that have worked and produced some pretty awesome tornadoes and or supercells to chase up here on the high plains. This is going to be more biased here in Colorado because this is where I live and I get to run the show, so I'm going to be biased. But this applies generally to anywhere where you have large changes of elevations, particularly New Mexico, sometimes even the Texas Panhandle, Colorado, Western Nebraska, and the Panhandle, all of Wyoming up into Montana, and a little bit of sometimes even the Black Hills in South Dakota as well. These are all kind of applicable uh, things that we can kind of discuss. Even though most of these cases will be focused in Colorado, you'll notice that a lot of these things are pretty similar, and you'll pick up on a couple of cues, which is part of the reason why I want to talk about them today. So, and actually, funny enough, let me go ahead and share my screen here. Get this all moved over. We're going to take a look at good old weather front here. There we go. All right. So here we are with good old Weatherfront. We love them. We love their products. And we're going to start kind of by using their stuff here because, funny enough, today, if you can notice here via the radar, there actually is a fair bit of thunderstorms here over the high plains, and actually a really decent supercell up here northeast of Cheyenne that a couple of friends of mine are actually out chasing. I live down here, kind of in the Greeley area, Fort Collins area, so I'm looking at this going, man, of course this happens while we get to do a show, right? That's part of the curse. You get to miss out on a little bit of weather, but that's okay because I'm happy to be here with you guys. So this is actually a really good example of an upslope regime that actually produced some thunderstorms, but it hasn't really done too much. And this is going to get into why I think it's important to look at negative cases or null cases, along with cases that obviously worked. It's an important thing when you're getting into forecasting events that you want to look at the big cases of, oh, this produced a huge epic tornado over here or an amazing supercell here. But if you train yourself on too many of those setups, you'll start to realize you might look at every setup into the future as why it'll work, not rather how is it going to fall apart. And today is actually a good example of why it's not going to work. And it's really simple. So a big thing to hear is that, yeah, we've got lots of storms here all across the high plains. Let's go ahead and just pull up the kind of wide radar here. We got see lots of different storms here. You've got showers and thunderstorms all the way up in Montana, all the way down the high plains, and even a little bit into the Texas Panhandle. So this is a clearly nice day of severe weather. And funny enough, there are apparently tornado warnings in Utah. So hey, take a look at that while we're following along with the show. Kind of neat. Didn't even see that there. But anyways, we see that we have lots of different storms here, and let's actually take a look at what's kind of going on observational wise. And like we talked about before, a really common way that we get kind of these upslope regimes is you get this flow of moisture on the backside of our weather systems. And right now, maybe to the untrained eye, you might not realize this, but there actually is a center of low pressure that's kind of sitting out here over, we'll say southeast Colorado, southwest Kansas, kind of that multi-state zone area. And you've got a nice little warm front that drapes out this way, kind of rough drawing here. You do actually have a cold front draped out here and a good old classic dry line somewhere along in here. And what you're going to notice is that you have this kind of natural, counterclockwise flow around our low pressures here in the northern hemisphere. So on the backside of these systems, especially if they kind of hang around for longer than a day, you can actually get these systems where they pull in moisture from north of the boundary and then go upslope. And today is actually a really good example of that. If we kind of play along with this, kind of go back in time here. This is earlier this morning. You can see that that cold front had already pushed well down here into the central plains here. You can see that low is really nice, well defined over here. You got that nice spin here out over Kansas. So this is the early morning, 6 a.m. Mountain time, and this is a pretty classic thing. You've got pretty much due northerlies here on over the high plains, and you've got lots of deep moisture in the summer, all pooled out ahead of it. So that really works to your favor in the summertime because usually in the spring, right, it's a little cool and cold on the north side of these warm fronts, so there's not too much moisture hanging out on the north side of these boundaries. But it's the late summer, right? We're in August. At this point, there's moisture pretty much everywhere that you're allowed to have plant life, I feel like at this point. So you've got plenty of moisture, dew point temperatures into the mid 60s, pushing 70 on the north side of your boundaries. Very common in the summertime. And this actually plays to our advantage here in Colorado. So we've got all this moisture and we feel like, okay, well, we got moisture. So that should mean maybe we have some severe weather chances. And we do. And as you notice, if you get these systems to kind of hang around, and especially if they weaken, those northerly winds throughout the morning will actually start to veer back kind of more towards the upslope. And that's exactly what happened throughout the afternoon today. You could actually see how those winds were pretty much dominantly out of the northeast. But as this low actually weakened, it went from about 1,003 millibars to about 1,006, maybe 1,005 millibars. Kind of a weakening, but it was slightly pulling away, kind of keeping that moisture nearby, slightly pulling away, slightly weakening, so its wind field kind of flattens out. When you start mixing, things veer, and in this case, it actually benefits us. And by the morning, you can already see here in Cheyenne, out in Wyoming, you have due easterlies at this point. And as we go throughout the afternoon here, now you can see even Colorado is now out of pure easterlies at this point. So this is a pure upslope regime through all of eastern Colorado into Wyoming. So hey, pretty good news for storm chasers if you're looking for to chase a storm. But here is the issue that we're going to get into, and we're going to have some fun with this. There's more than just dew points and chasing severe weather, right? You need to focus on what is happening with the upper level pattern and what's been going on over time. And so for this, we're going to jump over here to models. Go ahead and stop drawing because it keeps drawing. There we go. So let's go ahead and actually look at our upper air pattern, right? We're gonna choose a model from this morning. We'll do the 15Z wrap. So this is, again, if you're on a chase day, you're looking at the models, this is the 15Z wrap. This is something you see when you're looking at mesoanalysis in the morning, so this shouldn't be too much of a shock. And right now, we pretty much have this big old high pressure sitting out here over the, eastern US, just parked here, having dominant flow, and you have just your storm systems kind of riding that ring of fire, which is why so much of the Midwest here has been so dang active, is because this high pressure is just repeatedly thrown MCSs over top of them. But for us, we can look back west because an important thing to remember, the high plains tends to like troughing out west, which is what we have here. We have troughing out here to the west. You actually have a low here at 500 millibars, or excuse me, 300 millibars. A little bit of a wave here, but the jet is pretty much straight at this point. But you see that there are little kinks kind of generally in the flow here. So you do have a little bit of energy kind of traversing through, and that's important. The high plains generally likes kind of this very subtle flow. Kind of helps keep things at bay and whatnot. But as we're going to see here, as we kind of get into uh, the day here, as we kind of fast forward, we see that we don't really have too much flow that is really actually making it into our area of interest, right? We said that this was an area of upslope, but notice here we are having, 30 knots, even 15 knots down here, while the stronger flow is pretty much avoiding the area as well. So this isn't necessarily a very good sign for your upslope regimes that, we have one puzzle piece of, hey, we've got moisture that's funneled it up all the way up into the high plains. Great. The issue is we're not really getting any strong lifting or good enough lift just in general, any energy or forcing really to get things going. So we're basically relying on what does the composition of the thermodynamics look like. And unfortunately, a lot of profiles are going to look like this. And I'll actually try to pull a sounding here kind of here in Northeast Colorado, just a general point sounding. And what we see here is a supersaturated profile with virtually zero cap. This is pretty much the worst thing you want to see on the high plains because what it's going to guarantee is that the moment anything can convect, it will. We have pretty sloppy flow aloft, not too much organization, and a lot of instability. What does that mean? It means everything blows up because, right, as air hits the mountain, it's going to be forced to rise. That's instant thunderstorms always in the early afternoon between 12 and 2 p.m. You blow up these thunderstorms that don't have a lot of deep layer shear. I mean, look how on top of that themselves that photograph is in that mid to deep layer. You have virtually no deep layer shear here. You're just going to have blobby storms that kind of just hang around and aren't super very well organized. So, hey, we have the upslope, but the issue is seems like we were going to end up with a lot of blobby storms, more rainmakers, and no surprise at this point if we go to live radar. We pretty much just have that. Lots of blobby storms, a little more of a makeshift MCS of cells here. Nothing too crazy. This is kind of a basic monsoonal type pattern. We just have a lot of moisture in the full depth of the profile. There's no dry air. This is just not super great. So, you're going to just get what you get and you don't throw a fit type of a storm chase. And these are very marginal low end days. But that doesn't mean anything, that we can actually still have a pretty good day, right? If you look at Cheyenne over here, if we look a little bit more closely at the actual radar, we see that we have a actual, decent little supercell here. You've got, your nice flying eagle shape, bean shape with a little bit of a hook echo. I bet you this storm actually probably looks pretty decent if you're out here, off to the east, maybe to the southeast, kind of taking a look at the storm. So, even on days that it may not be perfect, you can still actually get some fun things to go chase, kind of in the area. So I wanted to start out with this as an example because this is a really fun, showcase of this is an upslope. It's not really going to do too much, but let's show you a negative example where it's like things kind of go blobby. But let's now look into some examples where things really got rocking and rolling. So this is going to be a lot of fun. So first thing I want to talk about though is elevation because this matters a lot. And you're going to see this in two parts. We're going to talk a lot about how does moisture behave as it goes upslope, as well as what does the upper air kind of look like across the board? We assume all our cases we're going to look at is you have moisture that is going upslope, right? That's where we get the term, is just air instability, moisture, whatever, is going uphill, going higher and higher in elevation, and that tends to change things in the way the atmosphere works. And an important thing to remember when chasing the high plains is knowing where your higher elevation areas are. Some very important ones that you should know, especially if you are a chaser in the central or southern plains, is the Raton Mesa, the Palmer Ridge, and the Cheyenne Ridge. Or excuse me, not Palmer, but Palmer Divide, but Palmer Ridge. You get the idea. So these are three natural zones where if you took a slice from north to south, you would get three bumps with ridges and valleys. That will induce various things because these elevation changes are actually quite drastic. Now, while this is in meters, we can still kind of use this as a proxy. You can get the idea that here around Cheyenne, we're at 17, almost 1800 meters. You go down towards Greeley, you've dropped 300 meters. This is important. We go to the Palmer, out here southeast of Denver, you're over 2000 meters. You go down to Pueblo, you're back down to probably, yeah, 1400 meters. So you get this thing is that there's this large change in how the landscape behaves. And an important thing to remember is that while upslope gives you lift, low-lying elevations hold your higher dew points, and that becomes a reservoir for a lot of big potential. And oftentimes, you'll see storms initiate off the higher terrain and move into lower terrain where there's better instability, and you seem to have really cool things go down. So when we look at these examples, this is going to be a really fun case example to remember these ridges here on the landscape and how they may generally change or shape how your storm chase goes down on a given situation. So, and for those curious, this website is just a topographic map.com. Really great map. Highly recommend them. They're awesome. So, let's go ahead and I've chased a few tornadoes. This is actually some of the cases that I've put into the Chase Archive. And if you aren't aware, we are also here at Storm Chaser Coaching partnered with the Chase Archive, and we use their stuff a lot. They are a really great place, and we're going to do a little playing around with a lot of their tools here that I hope to showcase. So this will be a lot of fun, and we're going to talk about some various storm chases that I've personally chased, as well as some that I've definitely not, and kind of how cool some of those cases are. So going into this, we're going to focus in on our first case is going to be a case from 2023. Maybe you recognize the case from this name, but it is the Holly, Grenada, Colorado, Kansas, like Johnson, Kansas, storm chase. This produced, and Jake took some amazing pictures. In the Chase Archive, we have this one listed as first. Some amazing pictures of tornadoes from this case. And I mean, look at this supercell tornado combo, right? This is the thing you want to be out chasing. And shout out to other Coach Cameron. He says, OMG, that first one. And I agree. These are some pretty incredible pictures of supercells and tornadoes that occurred on this day, and even two tornadoes at one time. So, right, we want to see things like this. So let's take a look at what type of things kind of would cause this type of a case. So first things first, we're going to start at the upper air. And at the Chase Archive, we have historical data here, so you can go back and kind of play through how things may have behaved with, how the day kind of went down. So I love this. This is a super awesome feature here. An important rule to remember with your basic high plains chases is flow, lift, upslope. Those are kind of the three things we're looking for. Give me 1 second. There we go. Okay. So with the three rules, we're going to start looking at kind of what does this case kind of look like. First things first, we're going to start here at 300 millibars, right? We want to stop at the top of the atmosphere. We want to see, is there lift? Is there divergence, right? We're looking for those very key features for things that are going to organize supercells. And on this case, in 23, we have a beautiful, very intense little shortwave moving through, and we have very nice diffluence here. So even though you may be outside of the traditional left exit region here and actually in the right exit region, look how much diffluence you have here where you have wind barbs out of the southwest turning into almost westerlies here. So pretty much you have air that is spreading apart as it kind of exits out of the trough, and that can induce lift. Now, keep in mind, this is not directly over top. This is close enough to give you that kind of vacuum effect of air separating aloft that helps induce lift. So we check the box there. 500 millibars, we see the kind of nudge of the actual subtropical jet. It might be a little tough to see for the untrained eye, but this is actually a really good merger of both the polar jet and the subtropical jet. They are two jet streams that kind of circle the planet. And they phased really nicely on this day. You can see the polar jet is kind of up here, tucked in around the actual trough, and a little bit of another speed max nosing right into Colorado. And generally, in storm chases that I've had the most success with, anytime you could be right at the nose, that front edge, leading edge of your 500 millibar trough at the peak of your storm chase timing, so like mid-afternoon, right when your storms get going, that's a really, really good sign. And for our case here that we're interested in, we are right there, right at the edge of this little nose as winds are separating aloft and that 500 millibar nose is punching in. Really good sign. Now we're going to go down to 700 millibars. Now, unfortunately, here, I don't think we can get temperatures here. Uh, so we'll have to just use flow here in general. But pretty much as things kind of go, we see that the flow pretty much just nosed right up in. And actually, at the time of interest, which is what this dot means, it means that's generally when the point of interest was occurring. We also see that there is a big old nose of higher flow that kicked in right at that peak time. And with elevation, 700 millibars can often act a little bit more like the low level jet because you have to realize that while the low level jet's normally here and 700 millibars is up here, the ground has come up. So that means the low level jet gets displaced higher. And sometimes at higher elevation, especially in eastern Colorado, the low level jet's actually a little bit more towards 700 millibars. So generally, we see that there is stronger flow kind of getting into that evening time, right at the point of interest as well. Also a very good sign. Traditional 850 millibars, no shock here. There is zero data over the Rockies because technically 850 millibars is in the ground. So, we don't have any air movement at that point. But we see that there is a big burst of flow right when that air is able to be above the ground and kind of accelerate in that low level jet. So this particular day, right ahead of a nice 850 millibar low level cyclone, you can see those closed height lines here. Very nice to see that there is a low pretty much over eastern Colorado, and that flow is accelerating right into it. And actually notice the angle of that wind, also southeasterlies. Then we go here towards the surface, and I'm actually going to play this one back a little bit. Notice here, this is 12Z, so this is 6 a.m. Mountain Time, 7 a.m. Central Time, and we see that we already have moisture pumping up into the high plains in the morning, that upslope, right? So probably all night you had this low developing out to the west, which helped kind of back those winds uphill, and they're pumping moisture in all day long, which is a really good sign. And we get into the afternoon, and actually you get this little pooling of moisture here and a zone of noticeably drier air here. And this is why I talked about the elevation. And so I want to quickly bring this up again. Notice this is kind of southeast Colorado, that you have this zone of higher terrain just across the Colorado border. And if we go back here, notice how we have drier dew points. That is because those are higher terrain or borderline mountains kind of in that zone where that higher moisture at the surface isn't all that good because it hasn't gone upslope. But notice how we're getting all this pooling of moisture all around this area of interest. So you're getting upslope right into your higher terrain and deeper moisture and instability just sitting there waiting for a storm to form off of the higher terrain. And as we kind of play along, you see that we actually get 70s dew points nosing right up into our area of interest. And actually, at the point of interest, we see that there is due southerlies or south-southeasterlies, 70 dew points. We already have the flow to check the box. This is a perfect recipe for beautiful supercells and tornadoes. And no shocker, that's what we got. So we'll go ahead and pull up the radar and satellite feature. Again, another really awesome thing. And we can kind of just play this out. We see that storms actually formed in an 88 over 55 degree dew point kind of zone. Very hot and dry. Kicked off to the east as it got into higher 50s dew points. Notice 68 dew points sitting in this lower terrain here, just waiting to be used. Flows right up in. This pretty much just never moves, always sat in this little valley. And you notice actually between this spot and this spot, notice how that dew point jumped up 6 degrees, a little bit probably from some convective contamination and rain. But notice though, as it continues, it kind of funnels along this edge of instability kind of along. You can see that fine line boundary here of where probably higher moisture was. And yeah, tornado time pretty much from this point forward, and that's how we ended up getting this beautiful supercell combo. So this is a really fun example because this was actually not a day that most people were down here. Because if I zoom back out, you're going to notice that there actually was an enhanced risk for severe weather and tornadoes actually up here, mostly focused here across Nebraska and Wyoming here into northeast Colorado. And this area was actually in a marginal risk. So if you're just chasing off the SBC outlooks, you miss this one. And I think this is why learning your skill of how to chase upslope is so important. This was a really cool example that we can kind of play around with that became really an amazing chase day for those that were there. So, going on from there, we're going to move on to another fun example, also from 2023, because we like recency, and my gosh, the 23 season was amazing. This might have been a tornado you've heard about. This was the Yuma, Colorado, Idalia, Colorado tornado supercell combo. A lot of chasers were on this one. This created quite a massive supercell that produced some big time hail that destroyed a lot of people's windshields and produced a very long-lived and I believe EF3 tornado. So this is a really fun example. So let's go ahead and we'll just jump right into it. So 300 millibars here. We're going to start at the top. We're going to start to kind of rapid fire this. What are we looking for at 300, right? We're looking for troughing out west and general broad flow. In this case, we actually have flow that kind of punches right into our area of interest by the point of interest. So a little different, but still troughing and actually northwest troughing kind of in that late summer. And funny enough, this actually happened on August 7th. So pretty similar timing to what we're in right now. That strong northwesterly flow bringing in a trough in, and this actually brought in a nice left exit region right ahead of this little compact shortwave. Some nice flow and lift here. You can see again, if I zoom in, southwesterlies to easterlies, so you do have lift kind of in that northeast Colorado zone. 500 millibars. Once again, we're looking for that jet to punch right into our area of interest, and it in fact does by the point of interest, so we check the box there. 700 millibars, we want to see a little bit of flow coming off the higher terrain, kind of help us get a little bit more change of direction. And we do, we see generally southwesterlies out over the eastern plains of Colorado. So we check the box again. At 850 millibars, we're probably not going to see the low level jet too well here, but we do generally see about a 15 knot low level jet kind of funneling into the higher terrain here with southeasterlies out over the lower terrain along the Colorado Kansas border. So seems like we're getting there. Seems like we have some good turning of the height with or turning of the winds with height, excuse me, with time. So hey, check the box there. Down here at the surface, we go back to see kind of how things were. Notice how we had kind of westerlies or southwesterlies, maybe even southerlies a little bit here in kind of eastern Colorado. Moisture was actually kind of pulling away. But as our low developed and that storm system came in, right, developed a little bit stronger lift, we were able to develop a situation and environment favorable for supercells. And this is very common where you actually don't get the full, upslope. You actually get a little bit more of a southeasterly, maybe south-southeasterly flow where the moisture is already kind of like funneled up into it and then just kind of hangs there. It just waits for your storms to get going. And we actually developed a nice Lee cyclogenesis here in eastern Colorado, a nice deep low 1006 millibars here that kind of kicked off the day. And notice here, even by the time of the interest, we actually had entirely backed to due easterly at this point. So clearly, as that low developed here, we actually became more favorable as the day progressed, mainly because that shortwave trough really came in, brought some stronger dynamics, developed that stronger low in southeast Colorado, backed those surface winds into the state, and we happened to get a very fun supercell combo. And actually here, let's go ahead and look again. Notice the station in Yuma, this little dot's kind of hard to see it, but it's 81 over 41. If you are storm chasing and you look at that, you'd think there's no way a tornado would happen there. But just to the east at Ray, 82 over 63. Much, much better conditions. And sometimes it can be a very fine line. Right here, you get a thunderstorm developed kind of on this little boundary, right? If I had a little draw tool, I would draw a little bit of a dry line-esque boundary here, formed right on the punch of that jet coming in, right at prime time. Storm developed slowly, Once it became anchored onto that boundary, it then just slid southeast along that boundary and would then go on to produce some pretty monstrous hail and tornadoes as well. But notice that station just sat right on the dry side of that boundary the entire time. I mean, the disparity of dew points here is 20 degrees or higher, 24 degrees actually. So there was a pretty monster dry line-esque elevation-based boundary kind of sitting here. And this supercell said, I want everything that you have to offer, rode that boundary, and produced some pretty epic stuff. So kind of a little bit different case, but some similar nuggets of information. Let's continue again. How about for those that really love storm structure, right? This was a beautiful, very laminar-based disk-shaped supercell in 2010. This may predate a lot of you who are listening in storm chasing, and I think it's fun to look back in a little bit more. I don't want to say historical cases, but this was 16 years ago now at this point. So let's go ahead and take a look at kind of what happened this day. And wow, no shocker, West Coast troughing at 500 millibars. What about 300? Yep, very deep, intense trough, digging in here right at the kind of early to middle part of June. So this is a very atypical type of thing to see in June. Um, Big old trough, but notice again, it doesn't really get into Colorado, and you actually stay in this right exit region of jets, maybe actually getting in a little bit of a left entrance region as this jet streak piece of energy kind of deflects off around this high pressure ridge. But generally, kind of in this transitional period of lots of different flow in here. But yeah, just, a little subtle forcing. Lots of flow, but very subtle glancing blow here in the summertime. Let's go ahead and just keep on working our way down. We see generally here as we kind of play along that winds are kind of fairly variable, right? There's not too much change here. Maybe by actual storm time, you're getting a little bit of convective influence with southwesterlies, but for the most part, winds are kind of variable until storm time, and then they kick back to the southwest as that system probably kicks off a bunch of convection. So kind of hard to say here what happens. At 850, we generally won't see too much of the low-level jet here because we are too high in elevation, but we do see that there is a mass response out over the plains, and that is going up into the higher terrain. So really good sign here as well. Good thing to look for. Here at the surface, this is a really good example of upslope, where we developed an intense low-level cyclone here out over eastern Colorado, right on the Palmer Divide. You actually probably got to 995 millibars just based off of this. Very, very deep, low-level surface, low pressure. And as it continued on into the afternoon, we can see that it kind of just was still developing, right? Because it didn't have that jet energy to eject off into the plains. It was still held back here. So we just kept deepening and deepening a surface low center and actually falling to 992 millibars, which is very low, especially for the summertime. And we see that upslope really crank back in out of the northeast here around this kind of warm frontal boundary because there's so much mass response happening in this case. And we see that deep moisture funnel in, upper 60s dew points kind of getting involved, but right at the area of interest, reaching that upper 50, low 60 mark, which in my opinion is very perfect, especially for if you're trying to chase those little more LP storms. You need a lot of dry air, so you don't want this deeper moisture getting involved. But I have to wonder if that deeper moisture did get involved. I wonder what kind of a monster tornado fest this may have been if that was the case. But what ended up happening was producing just a very beautiful LP. It was tornadic. It did produce some tornadoes. There's a really beautiful example of what that supercell did become. This was actually quoted as Simla, Colorado, but before the Simla in 2015. Just monster LP storms, tons of dry air, but a lot of really strong lift and deep moisture going right in. So you get these beautiful, very classic bell-shaped updrafts in Colorado. These are always super fun to see in person. Huge storm, huge, huge, huge storm. Really, really fun example. So let's go ahead and look at a really fun example a little bit, I won't say more recently, although to be fair, this was 2010. This was now in 2015. Maybe you've heard of this one. This was a classic cold core tornado situation that happened in eastern Colorado. I actually did chase this day. Funny enough, my house in Parker at the time was under a winter storm watch, and it was actively snowing while this storm, like 200 miles east, was occurring. So pretty dynamic system here. Produced multiple very photogenic tornadoes. One of them actually became a very stout tornado, but who in their right mind wouldn't want to chase this, right? This was a beautiful, beautiful supercell and tornado combo. To what I remember when I chased it, I believe there were four tornadoes, and one of them actually became decently large. So really, really fun case example. Let's go ahead and jump into it at 300 millibars, right at the top. And we see, wow, no shocker, troughing out west. This is a common theme, and I want to beat this into all of you who are listening. But again, this is a very different type of system. We've seen deep trough out west. We've seen very weak glancing blow from the northwest, or just weak troughing in general. This is a very intense trough getting involved. Right, we see this big old bowling ball at 300 millibars slamming right in. We get right into this left exit region as we start to kind of nose in. This was actually supposed to be a very big day. A moderate risk was actually issued for a tornado outbreak here in actually eastern Kansas. But funny enough, it didn't quite really work out. And a lot of people were left scrambling to get back west to chase this storm. At 500 millibars, we see that nose of that jet punching right into our area of interest. So, hey, we checked the box. At 700 millibars here, we see that we see a big, intense response. No shocker, right? With this big of a vertically stacked system, right? This low has not moved if we've moved down in the atmosphere. This is a very intense system. We see a big mass response. This is the type of thing that we love to see when we're out chasing storms. Now, at 850 millibars, we see that even still, with elevation negating much of this, we still do see that there is very strong flow out of the southeast or even due easterly as you get a little further north here. So there was a lot of mass response trying to fill the void that this dynamic system was trying to cause. So very fun storm situation here. And you can actually see as I progress here, that 850 millibar low really deepened, and you can see these winds really turn into this little center of circulation here. At the surface, we're gonna have some fun because when you woke up that day, you thought we needed to be in Kansas, and you start driving down I-70 and realize, oh, hey, look, this is actually getting pretty good. We're actually getting a dry line to surge. You're getting back southeasterlies underneath this low, mid 50s dew points. This is perfect for an upslope regime tornado fest. And actually, by tornado time, you can see here, this is a perfect example of how you get a very, very tiny warm sector that is very volatile for a tornado or a supercell wanted to produce multiple tornadoes. And because this also hung back so west, this wasn't able to actually produce any supercells down here this dry line. And so the entire moderate risk out here in Kansas and Nebraska entirely busted, seeing, if I remember correctly, almost no storms in this whole area. So it's a pretty horrific bust on the forecasting side, but the moisture just didn't get there. But where the moisture did get was enough for elevation, and it funneled right in between the Palmer Divide and the Raton Mesa, and that's where we had an amazing supercell combo. So this is the big system, and actually seems like they had this marked down as a enhanced risk, so maybe I'm misremembering. But this was a fun chase example. And you see as flow kind of comes in, notice it's not very warm. This is a early May case, but remember it was snowing here in Denver, so this, you're not going to expect this to be a crazy intense heating example. But we did have full sunshine here, just enough to heat the atmosphere. Notice the dew points were very weak here in the open warm sector into Kansas, but we started seeing those 50 dew points make it into the higher elevation, which is just enough. And we see this little tiny storm, this little itty bitty guy right here was actually the one that ended up producing multiple photogenic tornadoes to chase. And funny enough, the storm actually moved due north. It almost at times was jogging a little northwest at various points, producing tornadoes in its lifetime. So this was a very fun example where you had the dry line meet right into the warm front, and you had just one storm able to figure it out. A very dynamic example. It is not often you get such a dynamic system to be successful at producing tornadoes in Colorado. So this was a very fun unicorn-like event. But still, troughing out west, turning of winds with height as we kind of worked through the atmosphere, and strong upslope. Those seem to be the consistent boxes to check here. We're going to go to a case here that this was a familiar example for those that were paying attention to severe weather last year. I mean, how could you not? There were tornadoes literally everywhere, I feel like. This was a tornado that happened on a big moderate risk day and turned out to be a very big tornado outbreak with a very potent, potentially near capable EF5 tornado in Kansas that actually made a close pass by Greensburg. But earlier in the day, this decided to do a very big troll on all of us out chasing going east to Kansas. And I actually conveniently drove underneath the storm to go east and found out an hour later that it decided to produce a bunch of photogenic tornadoes here. As you can see here, Matt Coker here has a really good example of some of those tornadoes, and Elliot had a really good close view here of that tornado as well. Just beautiful, highly photogenic, kind of hybrid-esque tornadoes here to chase. Really fun example. And I love this case because you kind of get into this weird case of, is this enough moisture? Well, apparently it was. So, in this situation, if we go back to the upper here, spoilers a little bit, 300 millibars, again, big old trough, not very intense, open wave. Most of your deeper heights are a little bit more off to the northwest, and a big bowl of energy still waiting to flow in. But we generally have troughing, and we see that the strong jet streak here does eject into the high plains and the central plains here. And notice here we are right on this left exit zone where you have winds almost banking towards the northwest and winds banking towards the northeast here. So you have diffluence and divergence a lot likely in this zone. So the atmosphere is actively pulling air from below. At 500 millibars, we see that the flow is a little bit post ahead of it. So that might be a little bit of a negative, but there's still enough flow kind of hanging around the east side of the Rockies there with that southerly flow at 500 millibars between 30 and 40 knots. So just enough flow to maintain a little bit deeper of a hodograph here. And if we go down to 700 millibars, most of the flow is actually kicked off to the east at this point, which made this even weirder. And obviously at 850 millibars, we see that there is a little bit of turning here, right in the northern Colorado zone where you're getting due easterlies. But seems like, we're maybe not sampling this perfectly, but there was a lot of mass response. At the surface, this gets even weirder, where you wake up that morning and the dew points are in the upper 30s, low 40s, and you think, how in the heck are we going to get tornadoes here? Well, I thought the same thing as I drove east along I-70 and got about here. Dew points are now in the mid 40s, and suddenly we're doing tornadoes because, haha, funny, the state likes to do cool things to you. I love this case because it's a big example of I still have so much to learn in weather forecasting. But the big thing here is there was a big arced dry line. A little bit tough to see here, but when we show the radar, it'll be really easy to see. And a supercell developed right on the Palmer Ridge, moved into better moisture, right? Because it went from dew points in the teens almost at the surface to moving into 40s, almost 50 dew points. So that is a major increase of moisture. And it moved in, hugged that boundary with super steep laugh rates, started to produce a tornado, but there was enough deep layer shear around that a supercell also developed at the same time. And they tended to actually merge together, and the hybrid land spout became more of a tornado towards the end of its life. So very, very neat situation. And actually, this tornado was rated EF2. So not only a tornado, but a significant tornado as well. Let's go ahead and jump to the radar here. We can see that the moderate risk is obviously out here. Funny enough, I was actually out chasing here in northwest Kansas and chased a supercell to produce multiple tornadoes in Nebraska. Well, this beautiful little troll decided to show me that there's still so much to learn in meteorology. You see these nice towers develop right off the Palmer Ridge, south of Denver. They moved due north. There we go. So you get a few different towers, but then the main one started to get going. And at tornado time, I mean, look at this. This thing went from nothing to tornadic in, so much time, 30, 45 minutes. Pretty crazy, crazy stuff. But like the important thing to see here is what's happening at the surface. This is a great example of the Denver cyclone vorticity zone, where if you get southerly flow across the Palmer Divide, due to elevation dropping, it causes that wind to bank around, which means you get cyclonic or curvature or spin here in northeast Colorado. And it happened to also tie into a surface boundary arced where exactly it initiated, and it led to it producing tornadoes near the airport this morning. before anything even happened. I mean, you can see that there are virtually no storms here, and we're all sitting here in Kansas going, what the heck did we just miss? So I love this example because this is just such a wonky case, but it is a great example of how Upslope can really do funny things, and you can actually see the rest of the outbreak unfold much later as supercells developed further down the dry line and began the outbreak. So really fun example of Colorado Upslope. We're going to get through just a couple more examples. These are going to be the more crazy ones. This is the famous Windsor, Colorado tornado in 2008. It was a northwest moving wedge tornado at 11:30 a.m. Mile wide tornado in the morning, everybody, in near I-25. Crazy. This is a crazy situation, and we're gonna talk about it. Again, what's happening here? Big dynamic trough out west that is vertically stacked. We've seen a case like this. Seems like it just keeps getting more impressive as you kind of work your way down. So this is a highly dynamic system, big mass response, lots of spinning air, right in the left exit zone at 300 millibars. You know, you start checking all the boxes. And at the surface, we had upper 50 to almost 60 dew point, just reaching right underneath the surface low. And I mean, look at the surface low. This is lit. This is late May, and we're getting a surface low pressure of 982 millibars at that contour. This is a crazy system, and produced an obviously crazy tornado along with it. We go to the actual radar, and I'm actually amazed that we have this in the Chase archive, the actual radar and satellite of this event. Notice how it's very similar to last event. You kind of have this agitated instability out east and actually a moderate risk ready for tornadoes later in the day. You get this deep upslope wrapping right around the Denver cyclone, and we get this quick instability blow up of a supercell, and it blows up, goes right through west of Greeley to near Fort Collins, producing a near mile wide tornado rated EF3, and it hit the town of Windsor and did a lot of severe damage to homes there. And yeah, pretty wild case, but it checks the boxes. It was a we had it had a dynamic system, lots of lift, just enough moisture, deep backing, and deep upslope. And we just had favorable boundary interaction, right? You can see that this was clearly a dry line with dew points into the 20s and a warm frontal feature with dew points into the mid 50s here. And right at that intersection, the supercell ran across it, had so much energy, so much spin, produced a crazy big tornado. And there's the tornado actually moving through Windsor, Colorado. So pretty nuts situation here. Last two examples here as we kind of come to a close. The Laramie, Wyoming tornado. I could not mention Upslope and not mention this absolute nut job of a supercell tornado case. Just stupid photogenic. And I actually chose to not chase that day, and I will forever be hurt by that. But generally, how the case was is just southwest troughing and broad flow, but a little bit of a nugget of energy kind of moving in at 500 millibars. At 300, we see very weak flow as well. So nothing too crazy, but we see lots of ripples in the flow. So there definitely were short waves with a little bit of energy moving in. 700 millibars, not too much happening here, but we do see maybe a little bit of backing. So we check the box. 850, definitely some upslope, especially when you look further east. You see easterlies in Nebraska and South Dakota, and then to the southeast, we see nice flow there as well. So clearly the upslope machine was hard at work this day. And no surprise, this supercell case actually formed up here and moved southeast, which was really kind of weird, given the overall pattern flow being southwesterly wind. But it blew off up off a mountain, hit a boundary, which you can see here denoted nicely between a very dry air mass and a little bit more moist air mass, moved southeasterly and produced a very photogenic tornado. And this is going to be fun to show this because this supercell refused to produce a DBZ higher than 50 when it was producing a monster tornado. And you can actually see here it blows up right next to Laramie, Wyoming, and it moves southeasterly. And this is the radar presentation for when it was producing a strong tornado, which was just so mind-boggling. You'd actually see, even with this coarse radar, this little hole here is actually the tornado in progress here. So pretty nuts. It's not this guy, it's not this little guy over here. It is this lead little band of precipitation forming an absolute insane LP and crazy tornado combo, as you can kind of see here. So if you ever want to watch some fun tornado videos, I highly recommend watching this one. So really fun example of some upslope. And finally, if you know me at this point, I'm gonna talk about Simla because it's the greatest, one of the greatest storm chases I've ever been on, and it is the benchmark for me for amazing storm chases. And we've already been through so many cases, so we're just going to quickly go through this. But, let's check the boxes, right? We see that we have a shortwave that moves out of the area, but we get a little bit of a ridging. But we have general weak troughing out to the west with a stronger low well away. So, very subtle flow here. 500 millibars, just a little bit of flow coming off the Rockies, just enough to keep things from being too sloppy. 700 millibars here, we see that we have pretty much southerly winds here through the event, maybe southwesterlies that turn into southerlies generally in eastern Colorado. 850 millibars, we see that the upslope machine was hard at work once again, with by the afternoon hours, southerlies or southeasterlies pumping right in. And because I was there, you actually had due easterlies. And so this wind barb here along I-70 is actually accurate. Although I think this is a little bit, maybe this is Kit Carson, but you get the idea. Due easterlies coming into this storm, and it was nuts. And if we go now down to the surface, we can see that there was already moisture being funneled in by the morning. And we see that as the day went on, that moisture just continued to kind of funnel upwards into the area of interest. And by the time of interest, we actually had low 60s with higher dew points north and to the east of it, as this supercell wanted to kind of chug along between the boundary of very dry air and very moist air with lots of instability, steep lapse rates, just enough lift, and enough flow to keep things interesting. And if you know about this case, I will show the media again. This is the tornado, one of the tornadoes, I should say. This is one of many. Here's the anticyclonic EF2 tornado. Here's the main tornado again. There are just so many pictures and video from this supercell because this thing was just so unbelievably bonkers. I highly recommend going and watching a lot of people's videos and pictures on this supercell. But this is what she looked like kind of going into the day. And so we have the Lyman station here. So this gives us a really good idea. Storms developed in the early afternoon. You actually had a storm that was stationary that decided to split. And the main one moved deviantly southeastward with, I mean, 70 over 59 on the Palmer Ridge with a 15 knot easterly. That is a recipe for a fun time in Colorado. And this supercell banked southwestward, or excuse me, southeastward, and went on to produce, if my last count was correct, I think it produced upwards of 20 tornadoes. If you check the NWS database, you'll see that. So pretty crazy situation here. Really fun supercell. Just one of my favorite storm chases I've ever personally been on. And a really great example of upslope. And I mean, look at this just beautiful easterly flow out of over the entirety of the plains here. It only takes one storm. You had upslope over the entirety of this whole place, and there actually was a supercell here that produced a tornado up here near Fort Collins and Greeley, but the main show was this guy hugging the boundary here, and you can actually see that boundary on the fine line of clouds here. So a very eventful day for the Colorado upslope. So generally here, this is kind of some examples of upslope and an example of today of how, we're missing some ingredients, some basic simple things, but looking through examples of where clearly things went amazing and noticing that there are similarities that we can really draw from, even though there's going to be some various, tendencies and differences between events. But yeah, kind of a fun example here. We go ahead and stop sharing screen so you can see my face here. There we go. And yeah, just a very fun set of days to chase. And what I love about it is we can kind of look through history and see when they worked. And notice, I chose from multiple different years. So they're not something that happen all the time, but when they do kind of pop off, they tend to be one of the best storm chases you could be on in that year. So something to pay attention to when you're forecasting is look for those convenient or those consistent things that we look through with these examples, right? We want to see generally subtle flow, and if there's not subtle flow, if we have a dynamic system, make sure you're in that left exit region. Make sure you have deep upslope. Make sure that moisture, more than likely or not, is already present. Or is it going to be in time moisture? And is it going to be enough? And are boundaries at play? So I hope you guys learned a bunch. I always enjoy looking through these case examples. I always learn something every single time I look back through these. So I hope you guys enjoyed this little trip through some upslope regimes.
I enjoyed it, Hunter.
Still alive, not asleep. The teacher didn't put you to sleep.
No, man, I've been following along. In fact, you couldn't see it, but my eyes perked up. My whole countenance was lifted when I heard Simla mentioned. I was waiting for it the whole time. I knew it
Yep.
had to happen at some point, and
I'll
then
always find a
finally
way
it
to talk
did.
about it. Yep.
Yep.
Saved it for last. Save it for last.
There's that, I think it's called Godwin's Law, which is every conversation, if given enough time, will eventually make its way back to World War II and the Nazis. And I think we need to start something, the Fowkes Law,
Oh
which
no.
is every conversation, given enough time, will eventually make its way back to Simla.
This is correct. I'll allow it. I'll allow it.
You didn't know where I was going with that at first, but
Still a train wreck. No, I'm just kidding. I'm just kidding.
no, absolutely, we wouldn't have it any other way here at SEC, and definitely see we've had some great conversation going on while you were presenting.
Cool.
And right now, we are going to open up the floor if anybody has any questions about the presentation that Hunter just delivered, or any questions in general related to storm chasing meteorology. And as I do that, I just want to remind everybody that in order to get your question answered live, you do have to be a member. It's $3 on Discord. It's also $3 on YouTube, just slightly different paths to get there. On Discord, I'm actually dropping the question command into chat. So there is a link to sign up and become a channel member there, and then you just use that link to submit your question. And then over on YouTube, I'm going to create a Q&A right now. So I'm typing ask Hunter your questions here. And you can just click that button at the bottom of the chat. You can ask Hunter your question. Again, just make sure you are a channel member first. You click that little join button right below the video. It gives you the option to sign up for $3 a month, and you'll just feel good about yourself because you're supporting SEC and all the awesome stuff we do. So appreciate all you folks. All right, Hunter, we do have a question here from Kazaki to start things off. He says, I have two questions. Two, okay. Wow. All right. First, what is your favorite upslope event you chased? I'm guessing I already know the answer to that, but I'll let you take it for a moment here.
Simla.
Enough said. If you missed the part where he talked about Semla and the presentation, just go ahead
I
and
I should
rewind it in a few
clarify.
minutes.
I should clarify and say June 4th, 2015, Simla, Colorado. There's your official chase day. And
From what
oh, go ahead, go ahead.
I was just going to say, from what I remember about the story, it wasn't your dad's favorite chase day, correct?
Well, yes, partially because he wasn't there, but also because I smashed the car with 4.5 inch hail.
That's right. I remember the first time I talked to you about that on Chaser Chat, and
Yep.
you tried your
Yeah.
best to shield the old vehicle from the advancing hail, but you weren't quite able to do it. So,
Yeah. Yeah. It was a fun event.
all right. Second question from Kazaki. Would you say a lot of what you have gone over today is caused, or sorry, would you say a lot of what you have gone over is what caused the tornadic supercell in Utah today? I didn't even know there was a tornado in Utah today. That's cool.
Oh, yeah. It was actually funny because when we first started, I was looking at weather front and looked to the west and went, "Oh, look, a tornado warning. That's neat," and then continued on. But yeah, let's actually take a quick look. I can actually do this really quick because we have Weatherfront open because they're amazing and I could do everything from just their page. Let me go ahead and share my screen again.
By the way, I believe there's a big announcement about Weatherfront coming out a little bit later in the week.
Ooh. So
So,
yeah, let's take a look here. We'll just pull up wrap again here. Pull up the most recent one because we want the nice stuff. So what do we have here? 300 millibars, big old strong flow in general. kind of been getting into that left entrance, so not maybe not perfect per se. Oh, sorry, I was zoomed way into the future. That's much better. There we go. So yes, left exit, sitting right here, kind of some weak troughing in here. So subtle, strong flow generally across the top. So hey, seems to check that box. 500 millibars. Looks like we've got flow kind of punching right into the storm. The strongest flow sits right about in here. And actually, yeah, about almost 40 knots, 35 to 40 knots kind of in here. So seems to check the box there. 700 millibars. Looks like we have a little bit of a stronger punch from the southwest coming in. 850 is a little wonky because we're probably just too high elevation in general. So I would probably just discount this in general. Dew point here, I'm actually curious. Yeah, I was wondering if they actually had some decent moisture here, kind of tucked in on the west side along the Great Salt Lake and whatnot. But I'm actually curious if I pull a sounding here. Kind of what does the environment look like here? Very saturated, strong deep layer shear, little wonky here in the very lowest levels, but this is a great hodograph to develop a decently long-lived mesocyclone, that mid-level mesocyclone with some hail if the thermodynamics were kind of agreeing. Since this is a very saturated profile, I'm unsure if this would actually produce too much hail, maybe no bigger than an inch, inch and a quarter at the worst. And actually, we can take a look and see what this storm kind of looks like in general. Seems like we're a little well past of what happened with this warning. Maybe I just need to go back here. Ah, there we go. Yeah, look at this guy. Big old. I bet you that this thing was probably full of a million pea-sized hail. It's not often you get 75 plus DBZ and actually see huge hail. This guy was probably producing an absolute monstrosity of tiny hail kind of in here. Um, so yeah, pretty fun little supercell here. You can see it kind of arc in. Nice hook echo here. If we pull up storm relative
Oh,
velocity,
hey,
I wonder.
Hunter, real quick. I
Yeah.
apologize for not catching this earlier. I'm looking in chat, and it looks like people are saying that your screen is not being shared right now.
Oh no. You know what? Is that better? Hi.
There we go.
Haha. Technical difficulties. That's great. Anyways, well, let's run through this again real fast. Easy enough because we had everything. 300 millibars. There was that nice shortwave we were talking about, kind of moving through, a little bit stronger flow, kind of coming into the west side of Utah. 500 millibars. You can see that little bit stronger flow kind of nosing in. This is from the latest wrap here. 700 millibars, a little bit stronger flow out of the southwest, but then as we get towards the ground, things get a little wonky because we're pretty much just, again, underground. So we'll just kind of discount this unless we look at the actual sounding. And I pulled a sounding after looking at the surface dew points. We had some higher dew points kind of hanging around. On the west side of the state, pretty common, where you have some lower elevation, and obviously the Salt Lake can also kind of enhance some moisture there. But I pulled a general sounding here, kind of west of Salt Lake, and we see that it's a fairly long straight hodograph. Decent Cape profile, but very saturated. Maybe not the best at producing very large hail. I would expect at most an inch and a quarter at the largest, but generally a lot of hail if it was to create, because this type of a hodograph can very easily sustain a strong, long-lived mid-level mesocyclone and very favorable for hail production. And what we just were looking at before we were notified that I'm bad with technology is that we had actually a strong supercell here. And there you go. There's that nice 75 plus DBZ layer, really nice northeastward moving supercell here. And it briefly went tornado warned, as you can see here, because it wrapped up really nicely. So, but notice it ran across a mountain. So likely as it was moving along, flow got very channeled from the north here, and it probably helped induce maybe a little bit stronger low-level spin here. And we can see it hooked pretty nicely as it went up the mountain, and then as the occlusion cycle happened, it had completely been overcome by the merge of the other storms kind of coming into the area and the main storm just coming off the mountain. So well, I'm curious to see if this actually did end up producing a tornado. I don't know if these warnings indicated anything. Yeah, still just radar indicated, but very neat supercell here. Definitely check some boxes across the board to get kind of some supercells in the high plains or even the Intermountain West. So kind of a neat little example here, and I'm actually curious to see what it looked like on velocity. A little bit of bad data there, but it looks like as it went up, it looks like it did actually start to kind of wrap up here. So this is pretty dang neat. If I put these side by side here, if I do reflectivity and storm relative velocity and play this back. Yeah, look at all this wind it generated back behind it. Pretty fascinating stuff. Really strong storm here. Yeah, I'm not too sure if it actually did actually consummate the cycle, but considering the mountain bait probably went right up into the mesocyclone, you never know if there actually was a tornado or not. Yeah, I'm curious to see the satellite data later to see if a tornado did actually happen. Maybe right about in here, maybe it actually did try to produce a tornado really quickly. Trying to look at correlation coefficient, see if there's anything in here. And I don't know. Maybe. Definitely maybe. Very sus. I hope someone flies a drone over the mountain there and sees if there's tree damage because that would be really fun. So, very cool. Good example. Good example talking about this stuff versus more traditional high plains.
And Hunter, if you're bad with technology, that just means I'm bad at being a host because I should not have let you go on for like 5 minutes before I realized it. I was off in La La Land sending a message in our internal work chat on Telegram, so that's my bad. I'll take the L there.
Yeah, no worries. No worries. It's okay. We're here for fun. We're here for the fun.
Speaking of our internal work chat, did you know that our COOB, who of course you know from the Hunter Fowkes group chat, she was hit by a tornado 2 days ago.
Oh, in
That
Indiana?
No, in Ohio. So that
Oh.
derecho, it has been called a derecho now. By the way, I'm not just using that willy nilly. It has officially been classified as a derecho now, and it rolled through about 9, 10 a.m. somewhere in there, and there was a very clear path of damage from a park just west of her apartment building, and it traveled almost due east from west to east, and it was knocking down massive trees. There were a bunch of cars along the road that were crushed, and it was very
Oh.
different from the broader swath of straight line wind damage where everything was pushed in a single direction. There were, in areas where the tornado had went through, tree branches down, like I said, like actual whole trees that were uprooted. This is a really old area of town. There were a
Hmm.
few roofs that had been taken completely off, and there was
Ooh.
one second story of a building about 2 minutes down the road from her where it took off half of the second story, not just the roof, but it
Ooh.
it knocked down the actual exterior walls on the second floor, so the bedrooms were exposed. So it
Oh
was
man.
pretty crazy event.
Yeah, no kidding. I mean, that just without seeing damage pictures or knowing anything about it, just my general knowledge of the EF scale, that makes me think probably high end one, maybe an EF2. So decent tornado, very decent tornado.
Yeah, there was so the NWS has been doing surveys, of course, and whenever you have
Hmm.
an event like that, they are so overwhelmed with the number of damage reports that it's they might not even ever survey that area. Who knows
I
if
mean, you have to also think how many days of MCSs have you had, and you have to be able to determine what's damage from the day before and what's the damage
yeah,
from this. That does kind of
exactly.
muddle things.
But I will say this in the defense of it being a tornado, because again, I actually did a personal damage survey. Not that that actually matters much of anything, but so just to the north of where she lives, there is actual traffic cam of a circulation that passed over the highway and flipped a vehicle over. It
Yes, I saw that. Yeah.
yeah. So that's less than 5 minutes from her apartment,
Oh
and then
man.
about a quarter of a mile south of her apartment, there was a confirmed by a damage survey came out around noon Eastern time today. A damage survey confirmed an EF1 that traversed the almost exact same path parallel to the path that was by her apartment. So when you consider spin up about 5 minutes north of her, spin up about 5 minutes to the south of her, both with very similar damage, and then right along her road along that same west to east trajectory, I'm almost certain that it was a tornado that actually hit that area. So
Either way, whether it was a tornado or not, very strong straight line winds around tornadoes can be just as bad too. So
Yep.
yeah, fun.
So a little bit of SCC lore for all of you folks there at home. All right, Hunter, let's do a couple more questions, then let's get you out of here. I know you got the bebe to take care of.
Yeah.
Sanus Northeast Chaser says, whenever someone mentions Laramie, it sets off a neuron activation trigger. Not super related to forecasting, but more just a storm thing in general. So that storm was very laminar, just really nice in structure. How the hell did you have an intense tornado with that?
Yeah, and that's a really good example of a situation where steep lap rates really matter. I'm actually going to pull up a sounding here, and I'm actually curious because I know we have one in the Chase archive. Yeah. So let me go ahead and share my screen here again, and hopefully I will do it the right way this time.
I'm watching. I'm here for support.
Hey, look. Haha. Magic. Anyways, so this is at this exact point here, right when the actual supercell was doing the thing, which it looked like this, which is just crazy, frustratingly beautiful. And if I go up here to soundings here, we can see kind of how the atmosphere behaved. Here is the morning as it progressed, big nose layer and very shallow moisture, but then that upslope kicked in kind of right about here, middle of the afternoon, or early afternoon, excuse me. And we see that moisture kind of funnel back in upslope. As you can see, that you've got that easterlies that were fighting that mixing of the very shallow moist layer. And as we got closer to tornado time, we see that moisture really come back. And look how much that cape improved as that better moisture came in. We moved almost, yeah, 10 degrees Fahrenheit in dew points between 21Z and 23Z, and we like over tripled our cape. So you just crazy moisture being funneled into this zone. And this is a pretty typical hodograph and high plains out kind of shape where you have this is not very moist. This is actually fairly dry. These are not very close together. So this is actually a lot of dry air in this case. And your surface, I mean, still decent dew point spread here. I mean, 17 degrees Celsius or Fahrenheit, excuse me, is nothing too crazy here. This is a pretty typical. I like to say this is a two-shape hodograph. When you're on the high plains and you're looking for storm chases, these are my favorite. So remember that. Just stick that in your head. If you ever see a two-shape hodograph like this on the high plains, go chase it. It's probably going to be fun. And yeah, lots of dry air, very steep lapse rates. You can actually see down here in the bottom right, 0 to 3 kilometer layer was a 9.0 degrees Celsius per kilometer, and mean RH was 52%. That is dry. This whole profile is dry. And 3 to 6 kilometer, 8.5, the mid layer is 8.8. Effective inflow is almost 9. Like the hail growth zone is 8.2, so this thing was chucking big hailstones. So pretty fun stuff. This is a just stupid. This is just stupid. I was supposed to chase this, and then I said, "Nah, it's too far. It's probably not going to work. Moisture's not going to get in there." And I stayed home like an idiot. And 4 hours later, I was looking at my phone, wanting to die. Welcome to storm chasing.
Yeah, that sounds about right. Two more
Yep.
questions here. Questions are closed, guys, by the way, but we only have two sitting there anyway, so that's fine. Leo Morrison says, Uno reverse, Coach Hunter. What
Uh-oh.
happens when a storm rolls over a sharp downslope, like over a hill or into a valley or something like that?
Yeah, so this is actually a pretty simple thing. If you have a good storm, just in general, that rolls into suddenly very dry air, it dies. No, but I would highly expect the storm to probably go somewhere else. Storms will never willingly move into dry air if they can help it, because that their fuel source is instability, which is moisture, and if moisture evaporates, then you have no ability to generate more thunderstorm towers. So likely what would happen is two parts: the storm would run into it and probably try to go in an immediate different direction through a split, and whatever couldn't continue moving in a completely different direction would just move across, now probably die out. It would probably actually experience a very strong downdraft because suddenly you're very hot and dry if you move into that situation. So I would expect a sudden big outflow dump. That would be very cold and very surgy. So that would also probably be pretty bad for a storm chase. But most of the time, your supercells are moving away from dry air in general, or moving away from higher elevation. They tend to move from higher elevation to lower elevation in the high plains because that's how moisture generally works. So,
Now, is that similar then to how a storm will latch onto a boundary sometimes and move with a
mhm.
completely different direction than it would
Yeah,
otherwise move, is because it wants to keep that moisture being fed in on a conveyor belt?
yeah. I mean, if boundaries are basically just like you said, a conveyor belt of instability and steep lapse rates. So, and it's a zone of lift. So that's everything a thunderstorm needs to stay alive. And we actually saw a few cases where, and Simla is a good example of that. And I want to say not Deer Trail, but we looked at a few. Yuma, that's what it was also another example where a supercell completely deviated from everything it was doing, and Laramie also deviated from the general synoptic flow and said, "Boundary, I'm following it," and then proceeded to become an absolute beast at supercells and tornadoes. So, yeah, boundaries are very key. If you ever have a boundary next to any initiated point on the high plains, pay attention. That cool things will happen. Cool things usually do happen. Even if it doesn't necessarily mean a tornado, usually cool things happen.
All right, Hunter, and last question here. Is it feasible, by the way, this is from Sanus Northeast Chaser. Is it feasible at all to get like high base tornadoes outside of the plains? I mean, you could probably push 1 kilometer, maybe 1,100 meters. I feel like further east on the days you have enough heating to really cook the environments and get those higher bases, you're getting overall enough moisture to really have issues with evaporative cooling and downdraft strength. In early late season, you're relying more on WAA, and heating isn't as strong, so bases will just be lower as a whole. Do you think there's any possible way to get a real nice, beautiful LP supercell and tornado outside of the plains?
Oh yeah, absolutely. But it entirely depends on how much dry air you're working with. However, you can get that dry air. The way the high plains gets it is you just have it naturally nearby because higher elevations makes it harder for deeper moisture to get involved. So that makes things very easy to be very LP in nature. So that's an important thing to pay attention to. If you're out east, the issue is you have moisture source from everywhere. Most of the time, systems that travel from coast to coast will bring moisture along with them. So when they start out west, they're very dry because they slam into the west coast and they lose a lot of Pacific moisture. So they have to work through a lot of dry air and they progressively get more moist as they progress east. That's very common. So you're fighting the natural progression of things. And then also, where are you getting the dry air naturally? Because again, in the Central Plains, you can look immediately west and see tons of mountains and higher terrain to pull hotter, drier air to you. When you're out on the East Coast, there's nowhere to really pull that from because the Appalachians tend to be very cool and moist. So that's kind of more of your issue is it's hard to get the right amount of dry air and it's very easy to be too moist when you get further east. It is absolutely possible and it does happen, but rare, very rare.
So I did decide to let Greeny have one question. He came in and said, he asked, "Are questions done?" The answer to your question is yes, questions are done. So there's your
Yeah.
question, Greeny. Hunter, thank you so much for giving us this breakdown tonight. Really appreciate the upslope talk, and definitely going to be looking forward to your office hours next week. You've got the old back-to-back
Yeah.
show scheduled, so
Hey, I pushed this one back off enough because of life, so that's on me. And I look forward to seeing everyone again in office
well,
hours.
we're just happy to see your face out here, man. If you got to push it back 1,000 years, we'll still be here waiting for you. So
Noted. No, just kidding.